Good afternoon, everyone. I am Ben Shen from ChinaCon. It's very glad to have opportunities to be here, to have sharing our green construction in terms of BESS as a point of contractors. Before the topic, I would like to have a short introduction for our companies. And we are belonging to this CSCC, China State Construction Engineering Group, who is ranking number 14 last year in Fortune 500. And it has business over 100 countries and is the largest construction and investment group. And the local presence is CCDC, China Construction Development Company. And we established in Singapore since 1992. It's about 33 years. And there's a journeys for our company's development. We have different trades for like buildings, metalworks. We have infrastructure sectors. We also have property development. This is our company structures. Okay, here's our some projects. We have private residentials. We have public housings projects. And we have some infrastructure like MRT, tunnels, water treatment plants. And we have some mixed developments like hotels, bowling square factories, and hospitalization projects, hospital projects. And comes to the topic, BESS and microgrid. So you should know the equipment, the construction equipment like a tower crane, PM hoist, have intermittent power loads, which when the machine operates, it will be at a high electricity demand. When it is stop operation or in idle time, the current will be dropped very significantly. So conventional method to provide the diesel genset to make the maximum capacity, which will have cause a huge energy waste when at the lower power and even at the idle time. This is the traditional ways to do it. So that's why we bring the special battery energy storage system. It be charged by a smaller size of a genset or a smaller current from the power grid. Then it will be make the whole supply demand to meet the demand for the countryside. And it will be very flexible. So once you draw more power, then you can draw more. When the demand is smaller, you can draw small current from the battery set. And this battery is not the normal like a giant power bank. It is, you have to comply with the SCDF fire protection systems. You had to get the SCDF approval in front. And we have two modes for these systems, microgrid. One is the island mode, which is purely supply from the power grid to feed the power bank, to power grid to feed the power bank. The power bank release the electricity to all the site usage. And the hybrid mode is the combination. You have both power grid supply. You also have genset plus this power bank to supply the site. And we have starting this BESS and microgrid in our Perfect 10 projects. Now, currently, we have about 7 projects we are using this system. And we are estimating we are achieving more than 20% of the diesel efficiency. This is our Perfect 10, which is about is a condominium project. We have 2 units of tower cranes and also 2 units of passenger hoists. Before we bring in these systems, the power always trips when the tower crane is on, when the passenger is interrupt the site activities. So after that, we discuss with the vendors. They will provide this a big genset, battery. So with equip this one, we will achieving all the machines, all the equipments can be used concurrently, and also has a stable output of a currency of 50 amperes. So it's more effective for the site. The benefit from this project, we may not have like a cost saving, but it did help a site to have a continuous construction, to smooth the construction site. It's not interrupted by the power failure or even power trips. So it benefits from this aspect. And for our Diamond project, this is also a big RESI project. We set up two systems. One is the cluster one, power grid plus the BES for 3 tower blocks. And another cluster is the genset plus BESS to supply for another 4 tower blocks. This is the one. These 4 tower blocks, it has 4 tower cranes and 8 passenger hoists and other equipments. So conventional way, we estimate at least you have to set up 4 to 6 numbers of gensets to concurrently to provide the power supplies. But with these micro grills, we only use 2 number L-size batteries plus 2 number of 400 kVA synchronizer generators, which can solve all the power demand on site for these 4 tower blocks. So by running a few months, we also have an estimation for the cost saving, which we will reduce the diesel cost about 30K per month, which is converted to about 20,000 liters per month, and also equivalent to 50 tons of CO2 emissions reductions. So this is the benefit. I may spend a bit time to explain this smart microgrid, which is upgrading or version 2 for the current BESS plus the microgrid. Because this is one of the integrated power stations, which you have power grid supplies, you have solar panels installed at the site, and you plus the different sizes of genset. Why do that? I will explain later. And plus the BS become different sources of the power supply. And with the control by the AI-powered smart DB, you can make all the supply for all the site equipment like a tower cranes, passenger hoists, office, even if you have a CTQ, workers quarter on site. And before I illustrate, I may have highlight 2 popular science knowledge. First, if you are driving, you should understand when you drive at a very low speed, or even like a traffic jam, some highs or faster, it will consume more gas. Then the same apply to the genset. If you're running at the 60 to 70% of the capacity, is the most effective way to do it. Which means you use same amount of the fuel, diesel will generate the most electricity. The other one is if you're using a genset to charge the battery, there will be certain percentage of energy loss. And when you release the electricity from the battery, there will be also certain percent of the loss. So, which means if you if you use the genset to generate it's more efficient than genset through battery. So with these 2 considerations, we are using combinations. When you have a low demand of the site, the smart DB will draw the electricity from the small genset or even from the power grid if you have. Like in the evening time, you only have lightings, you even have some small demand of the electricity, then you will draw small site. And using a heavy machine, then this smart will trigger both or even battery to add in. So it's a process. When you're using more, you will trigger more equipment or genset to give the power supply. And currently, this one is not so smart yet. They just set some threshold. Maybe for certain your site using what amount of the kilowatt of the electricity, then you will trigger these 2. Then you more than that, they will. Then with the AI now technology, it will learn more the practice, the more data, they will become more smart and more efficient in future. So for this smart microgrid system, we will have is a slightly more efficient genset compared to the current. It will has lesser response time. This is also quite important technology. And we have a control panel with the AI. Then, and also we have a very platform for this EMS. It's a mobile end and also this desktop end or big screen on the side. You will see the usage of the power. Okay, so you will have this system. You will see individual equipment to be used or major equipment to use, very clear on site. Other, we have some PV panel for our MRT projects. And we also have like a electrical excavator and a portable, like a portable battery DB on site. Okay, that's all. Before I'm ending my speech, I would like to say, actually, I have some chatting with Obayashi researchers before the event. We just share some technology, like a construction, robotics, and this BESS. I just realized, although we are the competitors, but I believe the technology is no boundary. So we would like to welcome and also share the technology among all of us, and we make effort to the built environment and transformation industry. So thank you.